All right, picture this. You're about 50 kilometers north of Beijing, where the city blurs into mountains and green fields stretch as far as the eye can see. Nestled right here is something that looks, at first glance, like a massive silver sports stadium glinting in the sun. But it's not for football or concerts. This is the high-energy photon source, or HEPS. And trust me, it's about to change the world of science in a big way. Now, I've been following HEPS since the very beginning. I remember standing here in 2019, when this whole area was just grass and dreams. Fast forward to today, and the promise is about to become a reality. If all stays on track, HEPS is set to flip the switch and light up the world in December 2025. So, what makes this place so special? Well, HEPS is a synchrotron light source, one of more than 50 around the world. But it's not just another name on the list. When it opens, it'll be the most advanced fourth-generation synchrotron on the planet, built from scratch to push scientific boundaries even further. Here's how it works, in a nutshell. Picture a storage ring, kind of like a racetrack for electrons. As these electrons whip around, they're forced to turn by magnets, and at each bend they shed X-rays. Imagine rain flying off a spinning umbrella. But these aren't just any X-rays, they're super intense, super sharp beams, and scientists can tune them with mind-bending precision to use in everything from cracking the mysteries of new materials to peering into the deepest secrets of biology and nanoscience. And it's not just about power. HEPS is designed to operate at 6 GeV, that's giga-electron volts, and it's inching closer to a kind of ultimate scientific finish line called the diffraction limit. Basically, it means the X-ray beams can be made so fine, so coherent, that we're brushing up against the laws of quantum physics themselves. I walked through the experimental hall recently. It's huge and open, not like some of the packed light sources I've seen in the US. Right now, HEPS has 14 beam lines, but the plan is to expand to nearly 90, each one opening a new door for discovery. Just this past August, the team stored the very first electron beam, and now they're tuning everything. Boosting current, extending the beam's lifetime, and making sure each beam line is ready for the big launch. And the applications? Practically endless. Scientists will be able to use these beams to see atoms in action, test the tiniest vibrations in the Earth, build better batteries, study viruses, and so much more. There's even a massive 100-meter-long pipe out back to test how even the smallest tremors could affect their experiments. For people like Yang, who started out designing these beamlines straight out of university, this is a dream coming true. It's a once-in-a-generation leap forward, one that'll put China at the forefront of global science. So, when HEPS finally lights up later this year, it won't just be shining on a lab north of Beijing. It'll be lighting up possibilities for scientists everywhere, helping us all see the world in ways we never could before. Thanks for watching. If you're as excited about the future of science as I am, hit subscribe, and I'll keep you posted on the world's brightest breakthroughs.